All right, scientists, let's take some notes on fossils. We're still in Unit 7, Earth's History, and you'll see on this very first cover page some cool fish fossils, right? Now, in these notes, what you should do, you should have downloaded the PDF of fossil notes into Notability from Schoology. You're going to follow along with me, and then when we're finished, you're going to submit them to the Dropbox by 4 p.m. today. Now, inside the notes are a lot of really cool resources that you can check out. You can spend as little or as much time on them. If you're truly interested in this stuff, if you're bored today, if you want to come back to it, the links are going to be there for you. There's some really cool websites and things in here. And at the end, I'm going to suggest a video that you could watch too. It's pretty long. It's like almost an hour long. So like not required at all. But if you're totally into prehistoric history, it's really good. And so it's advertised on the last page. All right. So let's get going here. A giant ground sloth. I mean, maybe you've been to museums and you've seen some things like this where you're like, that looks terrifying, and it's absolutely huge. And fossils can help tell us a story, and they can help to explain the past and how things have evolved. If you look on the left, you can see that there's a human footprint inside of this giant sloth footprint. So, we've learned that people lived at the same time as this. What does it tell us, right? We've also found cut marks on the bones of the giant sloth, which were probably made by some sort of ancient type of human. And we can see the evolution of skulls evolve over time, looking more and more like the modern human as we go from A to N in this bottom photo. Now, you can think of fossils as sort of like a little, you're like, why is there an avocado here, right? Well, we can think about their formation as something like this, where, the little seed inside of the avocado leaves an imprint when we remove it. Oops, leaves an imprint when we remove it here. That's sort of like how fossils form. Like there was once a solid thing there, and the deposition of material around it leaves an imprint. Sometimes the materials like this, the bones would be replaced by minerals, which leaves behind this almost rock-like structure, which is then the fossil. But there are lots of ways to make fossils, including like just a footprint being left, right? That imprint, if we were to take the seed and press it into something softer, it would leave behind a hole of the same size. Same deal, right? Now, fossils tell a story. Okay, so let's write that down. Story, S-T-O-R-Y. But they can't show us the whole picture. Okay, fossils tell a story, but they can't show us the whole picture. Sometimes there's things that do not survive the process of fossilization or cannot. And on the right, what you see here, this is a geologic timeline, right, with only listing era and period. And we'll talk about just a minute about what's missing from this part on purpose, right? But the geologic timeline is divided up, and we start with in this case on this timeline with the eras, right, into the Cenozoic, the Mesozoic, the Paleozoic, and the Precambrian. Now check this out. If you can see this detail down here, like a Precambrian or Cambrian, sometimes people say it either way, is 544 million to 4.6. That should be billion years ago. Oh no, that's wrong. Okay, well, it should be a B. 4.6 billion years ago. All right, and so this is a huge amount of time, right, where we had very simplistic creatures, and then you'll see things kind of speeding up as we get more towards the present. And we're right now in what we think is the Quaternary period, although there is some debate about whether we might be entering a new period because of the rate of extinction of current creatures and plants. Let me show you here, though, a little bit more detail, right? The way that the geologic timeline starts is eons, and eons are going to be the largest periods of time. It's divided up into huge chunks, right? And then even a little bit smaller chunks, but still in millions of years, are eras, then periods, and then epochs. We're not going to have to memorize all of these types of things because it's just really too complicated and really a higher level geology than we really need. But I just want you to be aware that eons divided into eras, divided into periods, divided into epochs. All right. So they tell a story, but they can't tell us everything that happened, right? One question that, scientists get a lot is, all right, so cool, we've got these fossils and we have some evidence that, there's similar features between dinosaurs and birds. So what's the deal with that, right? Well, this link right here will take you to a video, and I'm not going to play the video for you, but I really do want you to play it, okay? It's only a few minutes long. You should pause my recording right now and watch this because it's very interesting. Why are birds the only surviving dinosaurs? Like, why aren't there T-Rexes anymore? What's the deal? Why did they decrease in size over time? How did they get to be able to fly? So this will be a really great thing. So go ahead and hit pause on my recording here and come back to it. Watch the video, Why Are Birds the Only Surviving Dinosaurs? And if you want to check some stuff out, there's some really cool things in this website too that you can check out from this Natural History Museum. All right, welcome back. I hope that you got a chance to watch that cool video and learn more about dinosaur to bird evolution. So, what exactly is a fossil? Well, a fossil is the preserved remains of a once living organism. All right, so you see some things down here. One is a little gruesome, like a petrified body, right? We've got some petrified wood. We've got an ammonite on the left. They're the preserved remains of a once living organism. So all these things were once living. All right. Now, why are fossils important? Well, fossils give us evidence of what lived on Earth before us and how things have changed. They show things like mass extinctions and can give us a little information about the how and why of what happened. They give us history of the climate, the environment. If you think about like these, the giant sloth, like why are things like that not living here anymore on Earth? And we can start to kind of piece some of that together with this fossil history. Now, the rock type that preserves fossils is, can you take a guess? Is it metamorphic, igneous, or sedimentary? Yes, it is sedimentary. Okay, because sedimentary rocks, what happens is the sediments bury and compact them and protects the living things. They other rock types destroy. Okay, extreme heat and pressure or melting, those types of rocks, those types of things would destroy any sort of remains of a once living thing. Now, how does this happen, right? Well, you can see this example with an ammonite. Now, ammonites are these sort of squid-like creatures in a rounded shell. They were very, very prolific. There were lots of them that lived here on Earth of different sizes through many different time periods. So we have lots and lots of fossils that are ammonites, right? But when an ammonite dies and it falls to the bottom of the sea and then sediments cover it. So, other animals can't really eat it, right? And the soft parts of its body start to decay. So that's why we don't really have evidence of that squid part, right? Just really the shells in a lot of cases. More and more sediments cover and it squeezes the shell, and that may remain or it may be replaced with minerals like quartz or limestone, and they seep into this solution before the shell dissolves. Over millions of years, movement in Earth's crust may bring it to the top. Maybe it's no longer part of buried under an ocean. It's now part of a mountain range, and we find fossils in all kinds of crazy places. One of the absolute best places to find fossils near here is in the Badlands, because that was once like a sea in that area. So you find really cool and crazy things, and then they got pushed up, and then the material around them is less hard, so it starts to be weathered and eroded away, and then you find these leftover and exposed fossils, okay? There are also really good places to find fossils around here where they've built roads or where they're taking out things like gravel, they're quarrying out that material, and you'll find really great fossils in places like that. So let's check out the recipe for a fossil, right? You're going to fill in some things here with me. So something, first of all, must be left behind, right? There must have been some living thing that left part of its hard parts, its body, its shell, its bone behind, or a trace fossil. Trace fossil is something like a footprint. You can also sometimes find an entire organism if you're super lucky. The process is that it needs to be buried quickly, okay? It needs to be covered up and started to be preserved, and so that it doesn't get like eaten like we just talked about, right? A really great place for the fossils to form is near water and minerals, and you also need lots of time for them to form, right? Because mineral replacement or preservation of a fossil takes a long time. Now, there are a few different types of fossils, right? Excuse me. A really important fossil is called an index fossil. An index fossil is found in many different areas, and it lived only during a specific time period. Okay, it helps us to know the age of rocks. So this weird thing which you saw in your that card sort that we did the other day of geologic time, it's called the trilobite. Trilobites are only found during a specific time period and lived in lots of areas. So we know that if you found a trilobite fossil, that it would be that you can age those rocks and they're the same age. Now, a trace fossil is something that's left behind, and it helps to show behavior. Okay, so some examples: footprints, dinosaur skin imprint, dinosaur eggs. Those kind of things that are left behind help to show behavior. Like they laid eggs, right? That's an important thing. All right. Some other types of fossils, we can have preserved remains. Okay, so stuff can be found inside of amber, made very famous Jurassic Park, right? So, but amber preserves whole entire animals, which is really cool. And sometimes plants too. Excuse me. Another type of fossil, we can find things left in tar and also in ice. Okay, so animals can be easily preserved in ice, and we'll see one of those coming up. Now, we can also have imprint fossils, and those are going to be where something is petrified, so replaced by minerals, or where a mold fossil, not like gross moldy cheese, but rather like something is molded inside of it. It looks like an imprint. And we can also have carbon film. Okay, now this one is a preservation by ice. All right, so here you see a frozen woolly mammoth that is 30,000 years old. Almost its whole thing, like its whole creature, was preserved in ice. And if you want to learn more about this, we got a cool article from the Smithsonian. Whoops, there's an ad. All right. Which is going to tell you more about the mummification of these types of creatures. Okay, sorry, there's lots of ads here on the Smithsonian channel. All right, but you can learn more about it there. All right. Now, we can also find behavior type things and relationships between different creatures from fossils. Here, we're showing pictures, footprints of a theropod and a sauropod, right? And you'll find more about this on this BBC website if you'd like to learn about it. It shows how these creatures were chasing each other. Okay, so you can see from the spacing of the footprints and how the different types of footprints about some of the behavior of these types of animals, okay? A theropod chasing a sauropod, which is really cool. And one more little, you can check it out, opportunity here, is that we have found human fossils and footprints, trace fossils of humans. And here is a really cool website that is going to describe more about the types of behavior that humans have shown through fossils, like how they've gotten food, the kind of tools that they developed, how they lived, what they stored things in, about burial and treating the dead, right? About recording information. So if you want to check that out, there's a really cool website here that will tell you about different types of behavior fossils. All right. Now, as advertised, if you're interested, have some time, and this is your jam, you can check out something called the Prehistoric Road Trip. Welcome to Fossil Country. I will also link this in our Schoology page, a link to this. It is like 54 minutes long, okay? So not an expectation, but I know some of you are really into this. And if you're not outside shoveling or playing in the snow, perhaps you want to check it out. Or maybe you do at a later time. I'll put the link in Schoology in today's folder, okay? So go ahead and make sure you've got everything filled out. Check out these different links here for some extra information and submit your completed notes to the Dropbox. Thank you.